Welcome, everyone, to this technical seminar. Today, the technical seminar is related to the topic to the FAIR principles here at ICMAB, but there will be a more general part and then a more specific part for ICMAB, more practical application. So the seminar will be given by 3 people from ICMAB. So Mark will start. Mark Martinez, that he did the PhD here at the ICMAB in the nanomold department. And since 2023 is the technician at the bioservice. And then Anastasia Carrillo, she will continue. And also she did the PhD at the University Autónoma of Barcelona. And since 2008, she is the technical manager of the electron microscopy service. And then finally, Alejandro Santos, that he's in charge of the library here at ICMAB. So he will do the more technical part, I guess, I think. So thank you very much. I think it's going to be very useful for all of us. So please, Mark.
So yeah, okay. Thank you for your, do you hear me right? Thank you for your kind introduction, Nuria. As she said, our seminar today is based on FAIR data and open data here at ICMAB. And I will give you sort of an introduction to this topic before we go full in depth. First of all, yeah, this open science tale goes way back, at least 40 years, to the to this essay of open science and closed science in democracy. However, it was at the start of the 2000s when different groups of researchers gathered around to publish some open access declarations in Budapest and Berlin. And from these years onwards, different funding agencies and governments from different countries have published their own their own open access policies. Also, our country, Spain, here we have in 2016 the specific open access policy for the Horizon 2020 project in the framework of the European Union. And then we have very recently in 2021, when the UNESCO tried to gather all these kind of different movements and concepts and try to draft the recommendation of open science. Open science is kind of like an umbrella term, is a combination of many movements that have been taking place during these last years, but it basically aims to make scientific knowledge openly available, accessible and reusable for everyone. And the idea is to try to bridge the gap between scientists and society, because sometimes we are like isolated and just thinking of our own research. But the idea is to make our processes for knowledge creation, evaluation, and communication open to other societal actors. And this is not only some happy fantasies that we may have, because in fact we are required by our funding agencies to comply with these open access principles. In fact, we have here the mandate, the directive from the European Union, and also the mandate from CSIC from 2019 that directly affects all of our research, making us comply with the fact that our scientific publications and scientific data have to be open to the public. But when we think about open science and access and open data, sometimes we use these terms interchangeably, but they are not exactly the same. So first of all, as I said to you, open science is this umbrella term coined by the UNESCO. That is a concept that combines various movements and practices that it's composed like many areas. However, we as scientists are mainly concerned with the scientific publications and the research data. And in fact, open access is an international movement that seeks to grant free and open online access to this academic information, publications and data, which is under this open science umbrella. But then when we talk about data, more specifically, we have the concepts of open data and fair data. And even though they are related, and sometimes some data can be open and fair at the same time, they are not exactly the same. Because open, by the strict definition, is data that is can be freely used, modified, and shared by anyone for any purpose. And in fact, all the institutional mandates try to make us use the less restrictive licenses for our data, so our data can be more freely used by everyone. And when we talk about fair data, in fact, these are guidelines to improve the findability, accessibility, interoperability, and reuse of digital assets. This is not to make data open, but to improve the way in we manage this data. And one of its core mantras is as open as possible, as close as necessary. But then this is not only something that is imposed to us by the funding agencies, it also is in our best interest to manage better our data. Because, for example, you might want to compare your results from the literature or search for specific data in the literature. You may want to reproduce results from the literature or from colleagues that you all know that it's not always easy. Or you may also want to continue a project from someone who left the group, and maybe you don't find exactly the protocols you need or the data. And the idea is that reproducibility and transparency are very important, not only for these funding agencies, but also for us. This is a report that is already old news, and you may already know about it, but I think it's still relevant. This is a survey published in 2016, in which 1,500 researchers were surveyed about reproducibility in research. And you can see here some concerning numbers in different fields. A lot of researchers said that they failed to reproduce an experiment, not only from someone else's, but also their own experiments. And among the different factors that influence this reproducibility are, for example, that the methods or the code are unavailable, or that the raw data is not available from the original lab. So this is one of the points that open data can tackle by making this research data more open and accessible to everyone. And another graph that I think is very interesting is that among all these researchers that were surveyed, some of them had already applied some actions to improve the reproducibility, but also a third of them had not applied any procedures for reproducibility, meaning that this is not only a matter of what the funding agencies told us, but it's also a matter of mentality. This is something that little by little we, as the scientific community, have to change our mentality and ideally all have procedures to increase or to enhance this reproducibility. Moving on, we are talking about data and metadata. And even though this may be evident to a lot of you, I will make just a brief introduction. Data would be raw facts, measurements, and observations. This is scientific data that has value by its own. This would be, for example, our measured spectra or microscopy images, for example, any data that is our scientific data set. And then we have the metadata, which is data about data. This metadata is dependent on the data that it describes, but this does not make it less important, because this is, for example, the conditions of your experiments, at which temperature or pressure you made a measurement, for example, or by whom and when. So in a very nice analogy that I found, the data would be our treasure, and then the metadata would be the map that guides us and helps us find this data. And so what can metadata describe? This is an effort by the partners of the European project, where they tried to have like a standardized vocabulary of the different kinds of things that can be described by metadata. And the idea is that there are a lot of things that can be described, and there are efforts to try to make these standards, but you should not be overwhelmed by this, because you are in fact writing metadata daily in your laboratory notebooks, even though it's in a physical format. So the idea is that ideally, in order to store and share this metadata, you should try to put it in a digital format. And one way to do this, even it's not a trivial effort, is to move to digital electronic lab notebooks. Here I have added a resource and nature protocol report for considerations about implementing these electronic laboratory networks, notebooks. But the idea is that we have to try to move towards a digital base in order to improve the way in which we store and share our data and metadata. Ideally, our metadata digital document would describe our sample or experiment or data set. And one thing that can help us to do this is a metadata schema. A metadata schema is like a template that says to you which is the kind of information that you could fill about your data set. A good analogy would be that your metadata schema is a chocolate box, and then your metadata document is this chocolate box filled with the different information that goes into each category. And for this, I also added some resources from the Digital Curator Center, schema.org, Dublin Core, and DataSite Schema. These are all schemas, but as I have searched through the literature, it seems that bibliographic metadata is already figured out by everyone. However, scientific metadata, I find that it's a bit more difficult to have a standardized way to do it. I think it depends on the field in which you are. And here I have added a resource that was shared by, to us through the NFFA project with this meta repo. This is a metadata repository from the European project that allows you to store metadata, but also has schemas for scientific data. So I think that you should find it useful. And then about formats, I don't know if you have ever received a data or metadata file that you could not open, but the idea is that this data metadata should ideally be in open formats. For example, you may have seen these XML or JSON files that are formats completely open. And for example, there is a lot of research equipment that already exports data in this XML file. And this can be opened by a wide range of softwares. Because when you work with different formats, there are ones that are open, for example, this XML, JSON, TXT, or PNG for images. And then there are not open formats, for example, the Microsoft Office formats, or formats from scientific software or from software that controls scientific equipments. And you should take care when you are trying to store or share this data, because sometimes the proprietary formats from this kind of equipments or softwares cannot be opened with other softwares that you have. So when looking to store or share this data, you should look for the export options in order to see if you find this kind of open formats. And if it's not possible to store this data in an open format, you should at least indicate to the repository or your collaborator which is the necessary software in order to open this data. And after this, how can you know if your data is fair? Anna will go after me.
Is FAIR. FAIR stands for findable, accessible, interoperable, and usable. And its goal is to enhance the value of data. It was developed to improve the management and stewardship of data. Why FAIR? FAIR ensures data is valuable, usable, and compliant with global standards, and promotes collaboration and innovation across disciplines. Emphasize the importance of data being usable beyond its initial purpose. For example, the data need to be available over time. The authors intend to provide the guidelines to improve the findability, accessibility, interoperability, and reuse of digital assets. Here is the link available for more information. The 4 core principles are findable. Data is easy to locate for humans and computers. Accessible. Data can be retrieved through clear protocols. Interoperable. Data integrates well with other datasets and tools. and reusable. Data is well described and can be reused for various purposes. Each principle is addressed to improve all the data. Now I'm going to explain each principle with more detail. How can someone find your data if they don't know it exists? It needs to be findable. For this reason, it's necessary to assign a global unique persistent identifier, for example, DOIs, and metadata describes the data and follow standardized schemas. Data is registered or indexed in searchable repositories, easy to find. The conclusion is metadata should be easy to find for both humans and computers. Here, the repository has the responsibility to make your data findable. Metadata need to be accessible. Ensure communication protocols, for example, like TTPS. It should be known how metadata can be accessed. For this, data is retrievable via open and standardized communication protocols. Metadata remains as is important. This metadata information accessible even if the data itself is restricted. Clear and transparent authentication and authorization procedures are needed. The protocol is open, free, and universally implementable. Here, especially the repository have the responsibility to make your data accessible. Data interoperability allows to data speak the same language as other datasets. Data should be exchanged and interpreted by humans and computers. For this, data must use common vocabularies, formats, and standards. These vocabularies follow FAIR principles, and metadata includes reference to other related datasets, and data supports automatic integration with other data and tools. Here, especially the scientists have the responsibility to make data interoperable in conjunction with the repository. The last goal of FAIR is to generate your data reusable, make your data reusable, or replicate. It should be clear how data can be reused. For this, data includes the real provenance and is described with rich metadata. And it adheres to community standards for data and metadata. And the data usage is clarified through clear licensing, for example, Creative Commons. It's important, it's essential to set type of licensing for the future users know how to manage your data. The SIG has a very valid tool to evaluate automatically the compliance with the FAIR principles. Its name is FAIR EVA. Evaluator, validator, and advisor for digital.psic. Here is hyperlink and link available. Here there are some examples of tools and resources. For example, repositories like Zenodo, Dryad, FileShare, metadata standard, Dublin Core, DataSite, schema.org, community initiatives, Go Fair initiatives, fairsharing.org, and software like a Fair Data Toolkit and DMP tool. And remember again the mantra. as open as possible, as closed as necessary. It should be specified who can access your data, under what condition, and whom to ask for permission to access the data. Remember, choose a licensee. There are benefits of FAIR principles. For example, for researchers, with increased visibility and citations, and it facilitates collaboration and knowledge sharing. Organization, it improves data management efficiency, and it supports compliance with funding and publication requirements. Society, accelerates innovation and problem solving, ensures data transparency and reproducibility in science. A real-world application of FAIR principles, for example, is a FAIR in environmental science. This map shows a collaborative monitoring of climate change data across global regions, demonstrate the importance of sharing global data sets for combating climate change. But there are some challenges to implementing FAIR. A lack of standardization across domains, and it cost of implementation. Limited resources for adopting FAIR practice. A need for cultural changes and education in data management, and technical barriers in legacy systems. For all of this is necessary call to action. Adopt FAIR principles in your data projects, advocate for FAIR practice in ICMAB-CSIC, and leverage tools and results to make data FAIR compliant. With all of these, FAIR principles empower better data management. They are essential for advancing science, technology, and innovation. For this, encourage adoption to ensure data and is a sustainable access. And how to do that, Alejandro explained open data at ICMAB.
Okay, after understanding what FAIR data are, now we will see how to turn them into open data at our center. In this section, we will try to answer some basic questions about the deposit datasets at ICMAB in a very practical way. This is a slide of an old presentation, but I like it. Some of the questions are, who does it? The library, the librarian, on a delegated basis. What is deposited? Datasets related to an article or not, or to a project, for instance. Where? In the institutional repository of CSIC, digital CSIC. When? Datasets can be opened after publication or can be embargoed. They can be published before or after the article they are related to. Why? To comply with the open access mandates of the funding agencies and to follow open science principles. And how? The process is somewhat more complex than with articles, but today I will try to explain how does it work. The mandates of the funding agencies that affect us are those of the European Union, the PECTI, that is a Plan Estatal de Investigación Científica, Técnica y de Innovación, the Institutional Open Access Mandate of the SIC, and the Severo Ochoa Call Mandate. Here you have the links of the documents that contain them. The images are hyperlinks. And these summary tables shows the validity of each mandate and how their content is very similar. Horizon Europe and el Plan Nacional indicates that a data management plan must be prepared. The deposit of a dataset in Zenodo, for instance, complies with the Horizon Europe mandate, but not with the specific one from CSIC. So by depositing the dataset in Digital CSIC, we simultaneously comply with all mandates. As open as possible, as closed as necessary. What is the meaning of this expression that always appears in relation to this topic? The obligation to make open access the datasets can have some exceptions. Here we see the one mentioned in the Horizon Europe mandate. Issues related to commercial exploitation, data protection, security, confidentiality, or property rights. The market in red are also in the open access mandate of the SIC. In some articles, we read the statement, the data are included, all data are included in the supplementary information. Is that true? Sometimes a data availability statement appears, such as data will be made available on request, but this statement does not comply with the open access mandate. The data must meet a certain quality standard, conforming to FAIR principles. And here are some links with useful resources on this topic. Digital CSIC has information and resources site. FAIR IVA is explained by Anna, is a URICI support service for FAIR data that measures the degree of alignment of the research data available in Digital CSIC with FAIR principles. OSF is Open Science Framework. It's a free platform for storing and archiving research projects, research data, protocols, and other materials. And electronic lab notebooks provides a comparison of software tools that emulate the traditional paper lab notebooks. A data management plan is a document that defines how data are managed throughout the life cycle of a project, from acquisition to archiving. It is required for projects funded by the European Union and the Plan Estatal. Templates for drafting a DMP can be found in Digital CSIC and in Horizon Europe website. A digital management plan may contain information on what data we want to make open, in which repository, under which license, or which tools we need to verify and replicate this data. The deposit of datasets in CSIC is made by the library on a delegated basis for researchers. The researcher must send two things to the library, the treasure and the map, an Excel file with the with all the metadata of the dataset, and the raw data that he wants to make open access, preferably compressed in a zip file. This is this Excel file that you must send to the library with all the metadata that the librarian cannot know before he upload the dataset to the repository. The authorship section is more complex than in an article. because it must indicate the different roles of the people involved in the creation and development of the dataset. And this is the ICMAB-CSIC has this template description of the dataset with all the information about each metadata, which we now will examine in more detail. All the metadata that the librarian does not have must be specified in the Excel file I showed you. First, the name of all the dataset co-authors must be provided. And the dataset title can be the same as the article or project is related to, or a different name. If the name is the same, the word dataset must be added in brackets at the end. To avoid having two records with the same title in the repository. The date of publication of the dataset is the date you upload it to the repository. The date of creation must be earlier. And additionally, this date is important because it determines the beginning of the right protection of the dataset. The dataset can be uploaded with an embargo date. For example, if it is to be made openly available simultaneously with an embargoed article. And the record handle is the persistent identifier of the dataset. It's created immediately when you upload the dataset. And ICMAB-CSIC assigns a DOI, to each dataset which will appear the day after the dataset is deposited in the repository. The table of contents is very necessary, especially in datasets with a complex structure and research data with several datasets. And the additional information is a section that can include any information that does not fit in the other fields of the dataset, such as important date, file content descriptions, methodology details, software requirements, etc. This is an important field because it indicates which research work is the dataset is related to, if applicable. The total size of the dataset must be specified. In principle, there is not file size limit. And also the format or formats of the data and the specific software to read, to view, and to reuse this data, indicating where the software can be found, and preferably open source software. As mentioned, the data can be opened from the moment of publication of upload with an embargo date. We choose which usage license we want to apply to our dataset. And if we do not choose any, the default CSIC license will be applied to the dataset. It's this one in this link, and it's a very open license, like a CC BY. The authorship types, the co-authors of the dataset must have different roles. The Excel table I provide defines each role, like contact person, that data collector, data curator, data manager, project leader, etc. It is not necessary to assign a name to every role, only to those relevant to the dataset. A single author might have multiple roles, and a role must be performed by several co-authors. Additional files can be added to our dataset, such as a README file, so that it can be correctly interpreted by people and machines. Also a code book, data dictionary, a file with more bibliography, etc. In Digital CSIC, we have a template for creating a README file. In the web of Creative Commons, you find the catalog of licenses. You can apply it to the dataset. The CSIC mandate recommends a CC BY license or a CC BY SA license. We have this Creative Commons license chooser tool of Creative Commons that can guide us step by step in selecting the license that we want to apply to our dataset. If you want, we can take a look. We don't know which license we want. That's why we are here. Of course, we want attribution. We don't want commercially use. We say no to remix, adapt, or build upon. We confirm all. And this data, and here we have the code of the license that we want to apply to our dataset, step by step. And finally, as we can see in this statistic, the number of datasets in Digital CSIC uploaded by ICMAB is very small compared to the number of articles, just over 1%. For the CSIC as a whole, it's an 8%, the red flags, the green flags. And so cheer up and go for it, and please send me datasets.
Thank you very much to the three of you. So I think it has been very interesting, and thank you for the effort to put all this data in this presentation. I think it has been very useful. So now it's open for questions.
Thank you. So I had a question about these different types of licenses. Does the CSIC recommend one specific one, or we can choose however we want?
You can choose. I always say it's your data set are your rights, so choose whatever you want. The CSIC recommends two types because they are the most open licenses, but you can choose any one of anywhere.
Okay, thank you.
Thank you very much.
You're welcome.
Can the one set of data be published in more than one repository?
Yes, of course.
Yes?
Yes. CSIC mandate says, please publish this in.
I'm thinking that if it has a DOI, and if you put it first in the CSIC repository and then in Zenodo, that will also have a DOI, the same set of data will have two DOIs.
Yes, I'm afraid that that's it.
But related to this, was one of my, can, for instance, Zenodo access digital CSIC or the opposite, digital CSIC act, because it's open, right?
Access
So
for export,
for
export data.
instance, if I'm looking for the data, so using the same DOI from Zenodo and CSIC, because it's open data.
Yes, the same, you can use the same DOI because there is a field I didn't explain that is that dataset related to this dataset. You can indicate that there is a dataset related. So I suppose I never found this in my experience. I never did this, but I think they will share the same DOI. I think.
Because you were mentioning, can you explain? I didn't understand that you're saying that digital CSIC is more strict than what the European mandate is.
No.
Was it clear? I don't know. I didn't understood.
No, but what you were saying, Anna, is in regards to the repository, right? Because in the table that Alejandro showed, each mandate says that you have to deposit the data in a trusted repository or a certain repository. The one in Horizon 2020, for example, is a trusted repository which is compatible with OpenAIRE, which is the infrastructure of open access for Europe. But yeah, the digital CSIC one is more strict because it says the digital CSIC one. Yes, because digital CSIC is
Yes.
OpenAIRE compliant.
There is a list of repositories and there is digital CSIC between them. So I said, if you deposit in digital CSIC, you simultaneously comply with all the mandates.
Okay, no, because then we found the people, for instance, in our case, they asked us to put everything in Zenodo and they had to be accessible with other softwares. So my question, if it's instead of adding it to Zenodo, I add it in digital CSIC, if they will be able to access it through in digital CSIC, because they want to retrieve the data. You think that they will be able to access it?
If I don't understand, if it will be retrievable
At digital CSIC.
through Zenodo or through
Through digital CSIC.
you will write the DOI of the dataset in the article. So because the publisher is requiring this data when you submit the article, I think. Is that true? They are asking for
Alejandro, la pregunta es si alguien fuera del CSIC puede acceder a los datos en digital CSIC. Yo entiendo que sí, ¿no? Eso sí.
Yes.
So anyone
it's
from
an
anywhere
open,
can
it's an
access
open
digital
access.
CSIC.
It's an
By
open access
definition, it's
repository.
open access. So that's it. Now I've got the mic. Can I ask a question? So according to the CSIC, as I understand it, I know it's you submit the data set when the article is accepted. But it could be you submitted the data set before the article is even sent so that referees can look at the data set. So is there a way to edit the data set in the process of publication?
Yes, you can always edit the dataset and you can change the metadata of the dataset. It's very easy. to tell to me, and I will do it.
Thanks. Any further question? So here, Alejandro, so at the end, what we upload is always the data set until now, because we are, as I understood, the metadata is the map, and the data is the treasure. So what we are uploading here at the end is always the files that goes, for example, on a paper, there is a spectrum, and this spectrum goes with a file with all the data. This is the data set. It's not just to make clear what is the metadata or what is the data. So I think what we are uploading is always the data, right?
I think, first of all, I think it's not super clear. So, because as he said, you can send him the data set all compiled in a zip file. I mean, you can send all the raw data, because usually the data sets that are uploaded to Digital CSIC, it's not just a set of microscopy images. For example, if your article has more results from different techniques or whatever, you put it, I mean, you could do it separately, but I think that what everyone does is put everything together in the file and then upload it to the repository. But then your metadata, how do you store the scientific metadata, right? Because there are scientific data files that already have metadata. For example, microscopy images already have this kind of information. But then if you want to give provenance on your experiment, you could use this the additional information. You can, but I don't know, you can put there a bit of information that maybe you could just build your metadata file and put it inside the dataset, and then on the structure of your structure file, you can say, and this is the metadata of I think it's not very well specified, so you have to kind of find a way to upload it. But in principle, you could put everything there, I think.
I think that the spirit is the letter R, reusable in the FAIR acronym. So you make it easy for the people that is.
It's not just the raw data, so it's also how you got this.
Another, because we made this seminar because Anna and I went to the NFFA course, which was nice, but I think very applied to the NFFA project and with some applications that are not widely used. But some of the things that they said to us about metadata is what is relevant metadata. And sometimes you think that just one type of data can be useful for the people that comes next to look for your data, but you don't really know what will be important for the people looking at your data sets. So you should put everything that comes to your mind about your data, because maybe some years later, someone will find a use for this data. So this metadata should be, as the FAIR principles say, as rich as possible. So you should try to give. It's not a problem. And also, Digital CSIC does not have a limit for size, so you can get everything you want in there.
There was
one practical question. Imagine, so we assign data sets to one paper. And let's make a very simple example. You have a TEM image and a magnetic measurement. So in the metadata, you have an entry for one type of measurement and another for the second type. Is not very clear to me. How can you, because the conditions of the measurement and the context is different, no? So you need to do like different, I mean, there is all these files that you have shown, the Excel file of the metadata, there is different categories. So
you have a table of contents with, I think, 500 characters or more. Yeah, and you can put a structure of the data with different metadata contained in the same zip file. But if you want to send me two data sets related to an article, you can also do this.
But he said that people tend to put all the data together.
Because it's
And this is convenient because you only have one DOI, but it's not clear to me how, in practice, you make the data fair when you have many types of measurements in one paper. So I think it would be very helpful if we could do a practical case. Like, let's take one example, 3 types of measurement, and let's do it now all together.
I agree.
Yeah, because to me, this is very like metadata. I hear this all the time, interoperable, but well, in practice, what it is.
Mar Tristan, you made a data set with all the data set of a project. Perhaps you can explain.
So what we made, it's from a project. We choose not all experiments. We take representative experiments. So in the case, well, talking more exactly, so we were, it's the POC project of Teresa Puig, where we made the scale-up of the synthesis of different propionates. And so we choose, and so we choose then to check that the propionate is good quality. So we choose an MR, then we choose spectrum, IR. So we made, how to explain? Because so one part of the project is the synthesis of the solids. Then the other part was to prepare the solutions. And the third part, it was the mix-up of with nanoparticles. So in fact, we classified the project in 3 different folders concerning one of each step of the project. And in the first one, so it was the synthesis of the solid. So we made the NMR folder with one representative with the raw data and a word explaining how to, well, yes, how to process this raw data to get the infrared spectrum. Or whatever. Then for TIM, so we put the pictures and we were classifying this by folders with, I said, this one step of the project concerns different spectroscopic or different data. So we made one folder for each and took one as a representatives. And then next to that, we get some files explaining how to, people that will get, and the raw data, so how they can manage, how they can arrive to this spectrum taking the raw data, no? And so well, we are not experts there. We are doing that as we think that maybe another person who can prepare these products, how they can check if they are doing properly. Well, I think that, yes, it was more like, I don't know if it's something like that.
Sorry. What I think it's, well, you put everything in the file with documents explaining, right, how to documents explaining how to process this data. The problem that I see, as I said before, is that bibliographic metadata is already figured out, and in fact, it's what it's asked of you in this repository. But scientific metadata, I think it's not very well standardized, And well, you cannot add it in a very well indexed way in the metadata because this additional field is just a text field where you can add stuff. So I think that practically what we can do is, as she said, put these files explaining each part of your dataset, right? But I think it's not very well standardized, at least in the tools that we have. But what I was gonna say is what you maybe we can ask la responsable del Digital CSIC. Podem preguntar. Sí. It's a bit what I think that we can do. I don't know if this answers your question, Martí.
Pero en un paper tienes experimental para cada cosa, pues tienes que poner un metadato de cada gráfica o de cada figura que tengas. Cada cosa es son tantos como el Excel file es para que suba la información arriba, pero tú dentro tienes un archivo que explica cada experimento que has hecho. Lo tienes que tener, si no nadie puede reproducir eso. Por cada tipo de experimento tienes dos tipos. Esto del fit en un Word se implica como... Pero dentro del Excel file, ¿qué hay? Es decir,
The raw data, you put the raw data. Well, so let's continue here. There was a question here, Mark, and then.
So for Mar, this was for a full project, and how many hours did it cost to do this work?
Excuse me.
The people who was doing the spectrum, no? Collect the raw data, I think maybe.
For the daily workflow in the lab, you produce a lot of data, but like here in the case of a project, maybe you select what, 10% to match maybe of what all the data you produce. But here, I think the idea is also to include the lab notebook inside all the data which is produced. This data, is there any idea of make use of all the data which is produced? For example, at ALBA, every single measurement is stored, is there. Maybe the metadata is not well curated and well developed, but they are on the way to do it. That really every single measurement is there and available after an embargo period for the full world. So, is this something that really people think will be one day implemented to every experiment in our labs?
Who knows?
Yeah, and then maybe last question from me.
I think the mandate of the European Union is that all of the information is inside of, is fair. Now they don't have means to check that everything is there. So it's talking about papers is super easy because you have grid and experimental and everything. But in theory, at least in the last project in which I am, the European project, we should put all of the data, everything. So that was my question for them is the CSIC going to pay any license for lab books, for electronic lab books? Yeah. And tablets to have, or computers to have in each lab.
There are free electronic lab.
You have to set them up so that IT costs associated.
Yes, it will. Yes. And probably computers for the lab in which people can put, because you need the computer to be in the lab to do that. That would be super nice.
Last question.
I wanted to answer Martí because he asked for the. Yes. Those are in an article, when I upload an article to Digital CSIC, I know all the metadata because they are in Web of Science, Scopus, and everywhere. But with the data sets, there are things I don't know. So I have to ask you, and are these fields, okay? No sé qué pasa. Bueno. These fields, author, title, creation date, etc. And the important one is the table of contents, I think, and the additional information, because they are the substance. No, I don't know. No? That is the treasure that you will afford. David?
Yeah, I just wanted to make a comment about this curation of all the data, right? I mean, that's a huge challenge if you get to the end of a piece of work and you have to do everything. So probably, I think most groups will want to apply a kind of a different way of working in the lab. Because if you're recording an infrared spectrum, to give an example, you know, that format is not naturally as a text format. And you talk to some of the people who've just come in to start a PhD, they don't even know how to generate a text file, right? Or how to use it. So, I mean, that's a real challenge from the very start, you know, to get all of your data in a format that can be used. I mean, Mark gave the formats that are acceptable, which are quite restrictive, I would say, you know. So you can't just take the data from the AFM machine and say, there you go, there's the data. In principle, you shouldn't do that, right? Because it's commercial software. So I think everyone needs to think pretty hard about how they can apply that to what they do every day, just to make it easy when they do come to prepare a data set, you know, because it's a big task, you know. So it's the thing you have to do day to day, really, I would say.
Thanks. So maybe we can finish here the discussion. For sure that you will get many questions, so many people will come to your office, I think, after this.
Yes, yes, of course. You will be welcome.
So this is going to be sent to all the people. So we will be able to, because there are many links and this, so.
Yes. We will send to everyone.
Okay. So yeah, so thank you very much to you.